All right, so today's notes, 11.4, is on two-way tables. How do you read and make a two-way tables? And then how do we create and interpret two-way tables? So a two-way table is a frequency table, we learned about those in 11.3, that displays data collected from one source that belong to two different categories. Joint frequency is each entry in a two-way table. So all four of these entries. And then marginal frequency is the sum of the rows and the columns in a two-way table. So example 1 is to find and interpret the marginal frequencies for the given two-way table. Remember that the marginal frequencies are the sums of the rows and the columns in the table. So the way that I like to set this up, I like to just call it the total. Yes, it's the marginal frequency, but it's also a total. So the total of yeses to cell phones would be 34 plus 124, which is 158. And then the total that said no to having a cell phone would be 18 plus 67, which is 85. All right, so then we still have the totals for the tablet. So I'll make those. The total that said yes to having a tablet would be 34 plus 18, which is 52. And then the total that said no to having a tablet would be 124 plus 67, or 191. So how we interpret these, 158 people have a cell phone, 85 do not have a cell phone, 52 people have a computer, and 191 do not have a computer. All right, example 2 is going to get a little bit trickier. You conduct a survey that asks 286 students in your freshman class whether they play a sport or a musical instrument. 118 of the students play a sport, 64 of those students play an instrument. 93 of the students do not play a sport or an instrument. Organize the results in a two-way table. Okay, so the total, all of the students were freshmen. You're asking whether they play a musical instrument or a sport. So when we set up our two-way table, we're going to have one side be instrument, and the other side be sport. All right, you can pause it for a second to create your two-way table. All right, so now we're going to reread the directions and see what music or what numbers they give us and see where we can fill it in. So 118 of the students play a sport. That means that these two columns for our total is going to add up to 118. I'm going to write total over here and total over here. All right, 64 of those students play an instrument. So 118 play a sport, 64 also play an instrument. All right, and 93 of the students that do not play a sport, also don't play an instrument. So no for both is 93. All right, now we're going to use those three numbers to find out all the rest. So this box I can find by doing 118 minus 64. So that box is going to be 54. And now I can add 93 plus 54 and figure out that this box is 147. And now I know that there are 286 total. That means that these two and these two add up to 286. So the number of students that said no to a sport would be 286 minus 118, which is 168. And then the number of students that said yes to an instrument would be the total minus the ones that don't play an instrument, so 286 minus 147, which is 139. And now I can use either of those two numbers to find the students that said yes, they play an instrument, and no, they don't play a sport. So 168 minus 93 is going to be 75. All right, so now we have all of our numbers filled in our two-way table. we included the marginal frequencies, and we even included the total number of students. All right, a little bit more vocab for you. Joint relative frequency is the ratio of a frequency to the total number of values or observations. So that's going to be the ratio of, say, this number to the total of all people that were involved in the survey. And the marginal relative frequency is the sum of the joint relative frequencies in a row or column. So that's still going to be like our totals at the end of the row or column. All right, so example 3, the two-way table shows the results of a survey that asked college-bound high school students whether they plan to major in a medical field. Make a two-way table that shows the joint and marginal relative frequencies. Before we make the relative frequency table, I want to find the total of each row and column. I want to find the marginal frequencies. This will also help us find the total number of people involved with the survey. So, all right, so the total number of students that said yes to majoring in a medical field is 225. The total that said no is 455. And the total number of juniors is 343. And the total number of seniors is 338. So that means the total number of students involved in this survey is 680. All right, so now that we know the total number of students involved, we can find the relative frequencies of each of those. So first I'm going to copy over the two-way table. All right, so I have major in a medical field, yes or no, and then the class is a junior or senior. So to find the number of juniors that said yes, they plan on majoring in a medical field, I'm going to take this number, 124, over the total, 680. 124 divided by 680 is 0.18. Most of the time you round these to the nearest hundredth because you could also write them as percents. All of them should add to 100%. All right, so the number of juniors that said no, they're not planning on majoring in a medical field, would be this number, 219, over, again, the total, 680. That number is going to be 0.32. All right, and to find the number of seniors that said yes, they plan on majoring in a medical field, I take 101 divided by 680, which is 0.15. And to find the number of seniors that said no, they don't plan on majoring in a medical field, I take 236 divided by 680, which is about 0.35. All right, so now I have all of the joint relative frequencies. I also want to find the marginal relative frequencies. To do those, I'm going to use the totals. I'm going to add the totals of each of those columns. So to find the total number of juniors, we're going to add 0.18 and 0.32, and that's 0.5. So about half of the students that were interviewed were juniors. And then to find the number of seniors, we're going to do 0.15 plus 0.35, which is again 0.5. About half the number of students that were interviewed were seniors. All right, and then to find the frequency of students that said yes, we're going to add 0.18 and 0.15, which gives us 0.33, meaning about a third of the students interviewed said yes, they plan on majoring in a medical field. And then to find the relative frequency of students that said no, we're going to add 0.32 and 0.35, and then we get a 0.67. So about 2/3 of the students interviewed said no, they do not plan on majoring in a medical field. All right, so some summary questions for you before we're done with notes for today. What is a two-way table? A two-way table is a frequency table showing data from one source in two different categories. How is a two-way table used to show joint and marginal frequencies? Well, you can ask the same group of people, maybe there's two different types of people, and saying yes or no. And you can compare them out of a total. How do you determine the joint relative frequency and the marginal relative frequency in a two-way table? You take that number, so that specific group, over the total number, the ratio, and it's kind of like finding the percent. The ratio of that per specific group out of the entire total involved in the survey. Okay, and how can you interpret a two-way table using the joint relative frequency and the marginal relative frequency? Well, kind of like we did in that last example, we saw that the marginal relative frequency of juniors was 0.5, and so was the marginal relative frequency of seniors. So that means about half the students surveyed were juniors and half the students surveyed were seniors.